Hello guys and welcome back. So in this video I'm going to continue with the properties of perpendicular bisector, in which I'm going to introduce the property of equidistance. But before we start, please make sure to subscribe to my channel and turn on the notification button. So to explain this property, guys, I'm going to use the given diagram in which we have the segment AB and we have line D, such that line D is the perpendicular bisector of this segment. As you see, line D should or must pass through the midpoint of AB first and must be perpendicular to the segment AB. Now guys, let's say that M is any point on the perpendicular bisector. If M belongs to the perpendicular bisector, then M is equidistant from A and B, which means that the distance AM is equal to the distance MB. And so guys, if you, let's say for example, if M is a variable point and M is moving on the perpendicular bisector D, then the distance from AM and MB, this distance will never, will remain equal. The distance AM and MB will remain equal. And so guys, also we can deduce here, for example, that the triangle AMB is at least isosceles. And as a result, that any point that belongs to the perpendicular bisector is equidistant from the ending point, which means that AM is equal to MB in this case. Now guys, I will consider two different cases in which if the point belongs to the left side or it's to the left of the perpendicular bisector. So consider the point S. As you see here, we have the point S, but S belongs to the left side of the perpendicular bisector. Now guys, any point, since S belongs to the left side of the perpendicular bisector, then this point is nearer A than B, which means that the distance AS is less than the distance SB. And same thing, if I have a point L such that L belongs to the right side of the perpendicular bisector, then L is nearer B than A, which means that the distance SB or LB, sorry, is less than the distance AL, or AL is bigger than LB. And so guys, as a conclusion, let's say that we have a point M. If point M belongs to the left side of the perpendicular bisector, then I can say that the distance AL is less than the distance MB. So if M belongs to the left side of the perpendicular bisector, regardless of the location of the point M, the distance AM is less than the distance MB. But if the point M belongs to the perpendicular bisector, which means that it belongs to the line D, then the distance AM is equal to MB, which means that M is equidistant from from A and B. And finally, if M is on the right side of the perpendicular bisector, and regardless of its location, we can say that M is nearer B than A. And so this is everything, guys. See you later.